This will be the talk about plant classification, specifically the science of taxonomy, which basically is the science of classification. So what we're looking at is sorting things. We're attempting to determine relationships between organisms. For me, it's mostly plants, but this happens with animals as well. This is learning how all things are related. Their backgrounds, their usefulness. Do they have properties that we might be able to take advantage of? Is it something that we can domesticate? We can't talk about things if we don't know what it is. And knowing what it is learning to sort them out. Why do we do this? Well, we have to be able to communicate with each other. We like to understand the world. We're human beings. Human beings sort things. We do this all the time. We do it with dishes. These are the clean dishes, these are the dirty dishes. The big plates are stacked here, the little plates are stacked there, the bowls go over here, and the glasses go over there. You might even do it with just laundry. Here's your clean laundry, here's your dirty laundry. Some people will put their t-shirts here and their socks there and the sweatpants go there. So that's all sorting. We do this from day one. You see parents walking with little kids saying things like, that is a cat and that is a dog. That is sorting things so we can communicate about them. So who did this to us? Right. Carl von Linné, that we call Linnaeus, is the guy that did this to us. If you click the link, it'll take you to a Wikipedia page if you really want to learn more about him, but it's not required. He was a Swedish botanist. He was actually kind of a jack of all trades, as many scientists were at the time. And in the mid-1700s, he was looking at how we named and sorted things, and he didn't like what was happening. And so he invented a system to classify things. And he started with kingdom, phylum, class, order, family, genus, species. We've modernized this a little bit, so now you'll see domain, kingdom, division. Sometimes you'll still see phylum instead of division, subphylum, superclass, class, subclass, order, family, genus, species, subspecies. You'll notice the bulk of the system is still there. Yeah, we've added to it because we have a lot more technology now that enables us to see differences that he couldn't see at the time because he didn't have the technology. Don't write this down. You don't need to memorize this. You don't need to look at this. But this is basically here to show you what a taxonomic classification could look like. And if we go down here to the very bottom, you'll see that the species here is red maple. Very, very common landscape plant, but you'll see that it follows a specific classification. So we have red maple, all maples, plants that produce sap, flowering plants. So you can see the categories get larger and larger and larger as you go up this classification system. Well, how would you do this? If you were to do this right now, what would you do? If we landed on some planet where they had all of these different organisms and you were trying to sort them out, what would you do? We could use leaves, we could use habitat, we could use usage. Are they trees? Are they shrubs? Are they flowers? Are they something that we eat? Are they something that we don't eat? You know, all of these things have challenges, obviously, because the leaves aren't there all the time. The leaves can be larger or smaller depending upon the environment that the plant is in. So what did he really do? He picked flowers. Why would he do that? The flowers are only there for a few weeks. In some cases, only a few days. Yeah, annuals have them there for a few months, but most plants don't have their flowers on there for a long time. So why did he pick them? Because they don't change easily. Right? If you look at how plants change over time, they do change. They evolve, they adapt, but the flowers don't change easily, because if you are a daisy that needs to make more daisies and you need another daisy plant to make your daisies, if your flowers suddenly can't interact with other daisy flowers, you're not a species for very long. So the flowers can't change easily, so that's why he used flowers. So some of the terms that we do see that sometimes cause confusion, here's a genus. Dogs, wolf, foxes all fall into Canis. Domestic cats and some jungle cats fall into Felis. Acer is the genus for all maples. It's a group of organisms with similar characteristics. So if you look at a dog, can you recognize all dogs? Even dogs that don't necessarily look like wolves? If a chihuahua or a pug walked into the room, would you recognize that as a dog? Would you recognize a pug is not a cat? How did you learn this? You learned to classify them. We learned to look at the different characteristics. All maples have certain things in common. And if you want to know what, go out and look at the little helicopters that they have. They may come at different times of the year, but all maples have those little helicopters. Then we're going to go down a little bit further and talk about a species. A species has a very similar definition to a genus, a group of organisms with similar characteristics. But we are adding that can reproduce from one generation to the next. So here the difference is reproduction. Red maples need to interact with red maples. If red maples could interact with black maples, very quickly you would not have red maples and black maples. You would have some hybrid between them. So red maples need to be able to breed with other red maples. Human beings need to be able to breed with other human beings to make more human beings. Think of a hybrid, like a mule. How does one get mules? You need horses and donkeys, right? Well, if you put boy mules and girl mules into a pen together, do you get more mules? No. How do you get more mules? You need more horses and more donkeys. So you have to be able to reproduce from one generation to the next. Now, a lot of times you're going to look at the language and say, oh God, all these names, they're in Latin, I don't understand them. Why in the world would somebody pick Latin? If you were to invent a taxonomic classification system today, what language would you use? I know what I would do. I speak English. I would pick English. Most scientists today would actually pick English because English is the language of science. What was the language of science in the 1700s when he was doing this? Latin. Latin was the language of science back then, so he picked Latin. It's actually worked for us because Latin's pretty much a dead language nowadays. People don't speak Latin, so it doesn't change. So we don't have to worry about the meaning of the word acer, which means maple, is going to change because Latin really isn't a spoken language anymore. So because we group plants into various families, we can see similarities, but I'm going to kind of go over a little bit some of the important families. You don't have to memorize this. You don't have to write it all down. You can click through to the links if you want to see a little bit more information about some of these families. But I want you to keep an eye on some of them. So these are some ornamental families. Notice this family here, and this family here, and this family here, because those families are very, very large families, and they show up in a lot of different places, not just things that we look at. Some of those families show up on things that are economically important because of their negative impact, and that's important to keep in mind as well. Obviously, we're concerned about our food supply. So if you'll notice, again, who shows up here? This family, the bean family, and the grass family. They're very important families. Now, imagine life without grasses. Well, you might think, oh, well, there goes my lawn. Okay, but the reality is, look at these plants that are grasses. You take away the grasses, and our entire food system collapses. Grasses are one of the most, you could probably argue that they are the most economically important plants on the planet. At any given summer, there are more corn plants in the U.S. than there are people on the planet. That's how important grasses are. We do eat from a lot of different families. So if you look at the bean family, peanuts and soybeans and peas and things like that. So we do eat a lot of from that family as well. If you take a look at other families, you know, we eat from a lot of different families. You personally might not eat a lot of carrots. You might say, ew, I don't like cilantro, and that's fine. But as a planet, we eat from a wide variety of families, even if none of them are necessarily as important as the grass family. So you don't have to memorize these or anything. I'm not going to ask you to memorize these last few slides or anything like that. But the take-home message here is we eat a lot of different plants from a lot of different families, but keep in mind the impact that the grass family has on everything we do. Food, clothing, bamboo, housing, bamboo, again, recreation, lawns, parks, ornamental plants, ornamental grasses, lawns, parks. So the grass family is one of those important families. Again, from a classification thing, the things to know are going to be what is the definition of a genus, how does the definition of a species differ from that, and what is taxonomy? It is the science of sorting things. As always, if you have questions, do not hesitate to get in touch.